Hello, welcome to this video. In this video we will see a question based on development of surface. Development of a truncated cone surface. Question is, a cone of base diameter 50 mm and height 70 mm rests with its base on HP. It is cut by a section plane inclined at 30 degrees to HP and perpendicular to VP. Draw the development of the truncated cone if the section plane bisects the axis. So first you draw a reference line. Now since it's a cone, top view will be a circle. So you draw a circle of radius 25 mm or diameter 50 mm and draw vertical and horizontal diameters. Then divide that into 8 divisions like this, keeping 45 degrees like this. So you can divide that circle into 8 divisions. Name that point as A, B, C, D, E, F, G, H and apex as O. Now after drawing that circle and dividing that circle, project all these points to the reference line. Mark the diameter as or radius as 25 mm. Now height of the object is 70 mm. So from here centroid, mark height of the object 70 mm using a chain line because it's a centroid axis. So from here you draw 70 mm upwards using a chain line. Do the dimension 70 mm. Now connect all these points to this apex like this. You want to use outermost triangle as a dark line. Now project all these points here. You can name those points as A dash, B dash, H dash, C dash, G dash, D dash, F dash and E dash. Now it is given that the section plane is bisecting the axis. So mark the centroid of the axis, that is half the center of, mark the half of the axis here, that is 35 mm from apex or base. Mark that point here, 35 mm from base. Draw that line like this and draw a line at 30 degrees like the section plane. Now this line, this is section plane, and section plane you can use a continuous line, two dot lines, a continuous line, two dot lines and a continuous line. So in that way you can draw section plane. Remaining part of that should be a continuous line. So mark the angle 30 degrees like this. Now name those points according to in the same way, in the same order we named here. That is, here it is the point 1 dash is on the line A dash, the point 2 dash is on the line B dash, OB dash, the point 3 dash is on the line OC dash, the point 4 dash is on the line OD dash, 5 dash is on the line O dash E dash, and 6 dash is on the line O dash F dash, 7 dash is on the line O dash G dash, and 8 dash is on the line O dash H dash. So in that way you can name those points: 2 dash inside bracket 8 dash, 3 dash inside bracket 7 dash, 4 dash inside bracket 6 dash. Those points which are inside bracket are invisible in front view. So this is the top view and this is the front view of the diagram. Now so since here this you want to get the true length of the line. So in the case of a cone, the extreme generator, this will be this extreme line, that is O dash E dash will be, or O dash A dash, any one of them you can use. So if we will use this one as the true length. So here this O dash E dash is the true length. Now project all these points to that true length line like this, parallel line. Draw from all these 8 points, you draw parallel lines to that line. So you'll get some points here. Now on measurement you can get the true length of the line is equal to 74 mm. So this line length is 74 mm. Now you have a relation theta equal to R by L into 360. That is, R is the radius of this circle, that is equal to 25 mm. L is the true length, which is 74. So if you substitute if you substitute R and L in this equation, 25 by 74 into 360 will give you 122 degrees. So that is the development angle of the development. Now you want to draw two lines like this at 122 degrees, having this length O dash E dash as length, that is 74 mm. So from here you draw two lines having length 74 mm and included angle 122 degrees. Now draw that arc like this. Draw that arc like this, having same 74 mm radius and center as this point. Draw that arc. Now divide that into 2, that is 122 divided by 2, that is equal to 61 degrees. Each angle will be 61 degrees. Now after dividing that into 2 divisions, you want to divide that into 4 divisions. That is this one angle will be 30.5 degrees. So then you divide that in, so you divided that into 4 divisions. Now you want to divide that into 8 divisions. Here you are taking 8 divisions, so here we are taking 8 divisions. So you want to divide the same 122 degrees into same number of divisions. So here it is, you divide that into 8 divisions. So 15.25 will be one angle. So in that way you can divide that angle 122 into 8 divisions. Here how many divisions we are taking? 8 divisions. So same number of divisions we want to take here. So now why we divide like this, first into 2, then into 4, then into 8? Because if you use directly, if you take angles, there will be some corrections here. So that is why this correction we want to distribute throughout, because 122 degrees, when you use protractor and mark into 8 divisions, you won't get the correct answer. So at the end there will be some correction. So we want to distribute that correction throughout. That is why we are dividing that into 2 divisions, 4 divisions, 8 divisions. In this way you want to divide. Next, once you divide that into 8 divisions, you can use thin lines to draw those lines, soft thin lines to draw those lines, because in cone, over the surface of cone, there is no such line. So there are no such lines. So there are no such lines. So you can use thin lines to draw those lines. Here also, outermost triangle should be dark, other lines should be thin. Now to get the points here, the point 1 dash is on the line OA. So get the true length of the 1 dash, that is distance from here to here. Okay, not this distance. You want to measure the distance from here to here. Use a divider and measure that distance from here to here. Okay, 1 dash corresponding to 1 dash, this is the point true length. So that true length distance here to this distance, you want to measure that by using a divider and mark the distance here and here. Next, 2 dash and 8 dash. So corresponding to 2 dash and 8 dash, this is the true length distance from here to here, 2 dash and 8 dash. So that distance from here to here, that distance you mark on using a divider, you mark that on H and B. Next, the point 3 and 7 are on the lines C and G. So OC and OG. So 3 and 7 corresponding to that point 3 and 7, this is the true length distance from here to here. Distance from here to here is the true length of the point is 3 and 7, 3 dash and 7 dash. So that distance you mark on G and C. Next, 4 and 6 corresponding to 4 and 6, the true length you are getting here, this distance. 4 and 6 are on the lines D and F. So this distance from here to here, this distance from apex to this distance, 4 and 6 projected this point, 4 and 6 projected here, you can get that distance here. That distance you want to you measure by using a divider, and that distance you want to mark on D on here, that is on D and F, this distance D from here, D and F. So one more distance remaining, 5 dash. So 5 dash is on the line OE. So that distance from here to here, 5 dash, that distance you measured by using a divider, and that distance you mark on the line OE, because the point 5 is on the line OE. So you can get some points here. Now use a smooth curve to draw that, freehand smooth curve like this to draw that curve. Okay, now you use darken this portion and this curve and here, and other part of this should be thin line. So this is the development of the truncated cone. Hope you understood how to draw this diagram. Please like this video and subscribe this channel for more such videos. Thank you very much for watching this video.